A question commonly addressed in the Haas service department is, what is the proper way to remove and replace the chuck on my Haas lathe? Today, Andrew will review the important aspects of removing and reinstalling the 10-inch chuck on this Haas ST-30 SSY. And as we proceed through the steps, we'll also answer several specific Haas Answer Man questions that our service department received regarding this process. William Kramer of Irvine, California submitted the following question to the Answer Man. I'm trying to unwind the draw nut on the chuck on my ST-20. I'm not sure why, but it seems really tight. I don't want to damage anything. Any suggestions? Let's watch how Andrew addresses this issue. Before turning any screws, Andrew unclamps the chuck and e-stops the machine when the chuck has reached the middle of master jaw travel. This places the draw nut in an unbound position. Now the nut can be loosened without damaging the threads. Andrew removes 2 of the 3 top jaw assemblies, leaving the other top jaw in place, and uses a large adjustable wrench to grab the jaw. Andrew loosens the 6 screws that connect the chuck body to the adapter plate, but he doesn't remove the screws yet. Take care not to pinch your fingers between the wrench and the surrounding machine surfaces. Andrew removes the last top jaw assembly and also the chip cover from the chuck center bore. Next, he attaches a lifting eye bolt to the chuck. And in this case, Andrew brings a rolling lift into position and attaches the hoist's lift hook to the eye bolt. Tension the lifting hook so that some of the chuck weight is taken up by the hoist. This will minimize the load on the draw nut as it is rotated away from the draw tube. Randall Faustenberger from Alberta, Canada was concerned about the best way to detach the draw nut. Dear Answer Man, in the past, I have damaged the draw nut threads while removing a chuck from my machine. Please help me out with the best way to do this. Thanks. The key is to generate enough tension with the hoist to suspend the weight of the chuck body so it is not bearing down or pulling up on the draw tube. This will allow the draw nut to unscrew easily and pull away from the threads without risking damage. Remove the 6 chuck mounting screws and set aside. With suitable tension lifting the chuck body, Andrew unscrews the draw nut counterclockwise from the threaded end of the draw tube. The nut should loosen by hand. If the nut is especially tight, do not force it. If the nut is not unscrewing easily, it means the hoist is either exerting too little tension or too much tension. Adjust the hoist until the nut rotates by hand. When the nut rotates easily, this is your indication the chuck is suspended at the correct height. Attempting to unscrew the nut while it is bound will damage the draw tube and draw nut. These are expensive and labor-intensive items to replace. Andrew unscrews it until he nears the end, then he hesitates and checks to see how far he still has to go. He's particularly careful to disengage the nut without damaging the threads. Andrew carefully rolls the lift away from the machine, brings the chuck to the workbench, and lowers it onto the tabletop. He tilts the chuck body over to rest on its front face. With the chuck body separated and moved out of the way, Andrew threads 2 of the chuck attaching screws into the adapter plate and uses the adjustable wrench again to hold the spindle stationary while the adapter plate screws are broken loose. Don't remove the adapter screws yet. The adapter plate is usually a very tight fit on the spindle's tapered face. Some hearty taps at the outer edge of the plate with a large dead blow hammer should unseat the plate. At the workbench, Andrew cleans both faces of the adapter plate. WD-40 works well to cut the grease and blows out any chips or debris stuck in the screw holes. Then, check for dings or high spots on both faces using a fine grit deburring stone. Spray a few shots of WD-40 on the face and lightly draw the stone across the face, feeling for a change in drag to indicate there is a ding or high spot. Don't push down. You're not trying to remove material from the entire surface, just any high spots that might be present. Rub the tapered bore to check for damage there as well. Carefully remove any nicks that are found. Why is it important to maintain clean, smooth mounting surfaces? So we can avoid the situation that Mr. Robert Thornton out of New Jersey encountered. I think I was a little hasty when I mounted my chuck the first time. I pulled the chuck again and found a small steel chip between the adapter plate and the chuck. The chip and burr it caused were lifting the plate up. With the adapter plate cleaned and checked, Andrew moves to the chuck and pulls the tapered wedge upwards until the rear face is just a little past the chuck body. He then lifts the chuck upright. He checks both sides of the chuck body to remove any chips or other debris found in the inner recesses. Andrew finds chips in several areas inside the chuck body. He uses a pair of tweezers to pull the chips out of the recessed areas and checks for chips lying inside the range of master jaw travel. With all visible chips removed, Andrew lowers the chuck body back onto its face. He sprays WD-40 on the rear mount face and cleans it thoroughly. Then, with a little more WD-40 added to the surface, he checks for dings and high spots using the deburring stone again. With the mounting surface smooth, he moves on to thoroughly clean the draw nut threads and also checks that the draw nut rotates freely from one detent position to the next. If it's been more than 6 months since the chuck was last removed, now is a good time to disassemble the chuck for cleaning and general maintenance. Reference the documentation available from the chuck manufacturer for the exact steps involved in servicing your specific model of chuck. Move to the spindle face and clean it with WD-40 as well, again followed by a check with the fine deburring stone. With the spindle face prepared, it is ready to accept either our original chuck or collet style work holding. Now we will quickly demonstrate how the collet chuck is mounted and then return to installing the 3-jaw chuck. Collet chucks grip the workpiece as well or better than the most accurate set of soft jaws. The collet chuck body attaches solidly to the spindle face and the draw nut connects the collet to the draw tube, which compresses the collet in against the chuck body, gripping the workpiece. Andrew starts with the draw tube in the unclamped position and he cleans the draw tube threads. Next, he cleans both the inner and outer threads on the draw nut. Carefully thread the draw nut onto the draw tube until it reaches the face, and back the nut out a quarter turn. Actuate the chuck pedal to bring the draw tube back in towards the spindle. Spray some WD-40 on the collet body mounting face and lightly check for burrs with the deburring stone. Then clean the mounting face and taper. Carefully mount the collet body with the spindle dog engaging the recessed alignment hole. Thread in the bolts to secure the collet body. Carefully clean inside and outside of the collet to ensure no chips or other debris impede inserting the tight-fitting collet. Actuate the clamping circuit again to bring the draw tube to the unclamped position. Now, insert the collet into the chuck body. It is a tight and accurate fit, and it may hang up slightly. A few small taps with a light mallet will generally align it, so it will fall into place. For the make of the unit we have here, we need to rotate the collet counterclockwise to engage the draw nut threads and bring it towards the chuck body. Don't forget to install the anti-rotation screw in the collet chuck body. With the collet slot aligned with the screw hole, thread in the anti-rotation screw and tighten it. Refer to the collet documentation regarding the proper adjustments for gripping your material. Removing the collet chuck is simply a reversal of the installation steps. Now let's get right back to finishing our 10-inch power chuck install. Mount the adapter plate on the spindle face, aligning the spindle's locating dog to one of the recessed holes on the adapter plate. Andrew inserts the 6 connecting screws and also 2 of the chuck mounting screws. Along with the large wrench, these will again keep the spindle from rotating. Torque the screws to the value recommended in the manual that came with your chuck. In our case, Andrew torques these M12 screws to 80 foot-pounds. If for any reason you think there might still be contamination or something else cocking the adapter plate, then attach an indicator to the spindle bulkhead and check the face runout of the adapter plate. The runout should be less than 5/10,000ths at the edge of the adapter plate. Now we're ready to mount the chuck body. Place a few dabs of anti-seize or chuckies grease on the draw nut threads. Andrew brings the rolling hoist back to the table, lifts the chuck body, and moves the chuck back to a position beside the adapter plate, where he carefully adjusts the lift to match the heights of the draw nut and draw tube. The draw tube is still in the same mid-travel extended position where we e-stopped it earlier. Bring the draw nut up against the threaded draw tube end and slowly start the nut rotating clockwise using the nut drive tool. Don't force the rotation if it becomes difficult. Andrew notices the draw nut is not screwing on easily. He unscrews the nut and pulls the chuck body away. He rechecks the alignment, cleans the threads again, and checks for any thread damage. He adds another light coat of chuck grease to the draw nut threads and again visually checks alignment of the draw nut and draw tube. He restarts the draw nut and this time it rotates easily. He continues threading the nut until it is about 3/4 engaged on the draw tube thread. Next, make sure the chuck attaching screws also have a liberal coating of anti-seize or chuckies grease. Align the chuck body holes to the adapter holes and install and hand tighten the 6 screws. Andrew detaches the hook and moves the hoist out of the way. He installs one of the top jaws to counter spindle rotation. He sets his torque wrench to the recommended torque value and torques these M16 screws to 185 foot-pounds. Andrew removes the single top jaw assembly and then actuates the chuck, and e-stops the machine just after the draw nut has moved away from the unclamped position. He continues threading the draw nut clockwise, inwards, until it bottoms against the end of the draw tube thread. Then he rotates the draw nut 2.5 turns in the counterclockwise direction. This will position the master jaws close to the correct point in their travel range. Now energize the chuck and check that the number 1 master jaw indicating mark aligns to the travel range marks in both the clamped and unclamped states. Andrew notes that the jaw indicating mark does not retract far enough with the chuck fully unclamped and travels too far as it reaches the fully clamped position. To readjust the draw nut in the unbound state, he presses E-stop again at the midpoint of master jaw travel. He rotates the draw nut 1.5 turns in the counterclockwise direction to move the jaws outward. He checks the travel again and finds the limits are now correctly set. When clamped, the entire chuck and draw tube assembly is held tight by clamping force. But you might wonder if the draw nut can move out of adjustment when the chuck is moving from the clamped to unclamped position. There is a spring-loaded ball inside the plunger nut, which locates in detents on the draw nut. The ball clicks into place, locking and maintaining its position. Reinstall the chip cover. The top jaws can now be installed, and this chuck is ready for operation. For the 6 and 8-inch chucks used on the ST-10 and ST-20, many people will choose to remove and install these smaller chucks without the aid of a hoist. The 6 and 8-inch chucks have integrated adapter plates already mounted to the back of the chuck, so the chuck comes off and goes on as one integral unit. Removal is similar to what we just showed for the larger 10-inch chuck on the ST-30 SSY. But let's review the important differences. Andrew e-stops the machine as the master jaws are unclamping and stops them at the midpoint of travel. Again, this places the draw tube and draw nut in an unbound state. He breaks the chuck screws loose, but doesn't begin taking them out yet. He removes the top jaws and dust cover. Now he needs to unseat the chuck from the spindle face and taper. A good tap with a dead blow hammer is usually all it takes with this size of chuck. Andrew removes the 6 chuck screws. Then he double-checks that e-stop is engaged. And since he doesn't have the aid of a hoist, Andrew uses his knee to support the chuck, making it easier to keep its weight off the draw nut as he finishes unthreading the nut. Remember, ensure the draw nut rotates without binding, or the draw tube and nut will be damaged. Now, let's look at an easy method for installing the 8-inch chuck on this ST-20 when you don't have a hoist at hand. The 6 and 8-inch chucks are not very heavy, but you should never attempt to remove them without a hoist if you feel there is any chance your safety is at risk. Andrew begins by making sure all the chuck and spindle mounting surfaces are clean and free of burrs, and the draw tube and draw nut threads are lubricated with chuck grease. He actuates the draw tube to move it to the retracted position. We see the draw tube retract into the spindle bore and stop at the end of travel. E-stop the machine. He carefully lifts the chuck body, making sure to have a firm and secure grip. He finds one of the recessed pockets in the chuck's back face, which he will align to the spindle drive dog. He positions the chuck in his hands so the pocket is directly across from the drive dog. Andrew places the chuck delicately against the chuck face. Hold the chuck steadily in place with one hand while threading a chuck screw inwards until it is snug. Continue to thread in the remaining 5 chuck screws and snug all 6 screws hand tight. With the chuck attached to the spindle face, look into the chuck bore to check that the draw tube end and the draw nut are well aligned. Here we see the draw nut is sitting slightly forward of the draw tube end and looks well aligned to the draw tube, as we'd expect. Andrew engages the nut install tool and pushes it inwards until the draw nut gently touches the end of the draw tube. He begins threading the draw nut in the clockwise direction, feeling for any binding. If any binding occurs, the chuck should be removed and checked for cleanliness and burrs or chip contamination. Once the draw nut is threaded on about halfway, it will start to become tight to turn. Stop rotating. Actuate the clamp circuit so the draw tube begins opening to the extended position. E-stop the machine when the draw tube gets to the midpoint of travel. Now, continue tightening the draw nut until it bottoms out lightly against the draw tube. Next, rotate the draw nut back in the opposite direction 2.5 turns. Just as we did on the 10-inch chuck, a small adjustment in draw nut rotation may be needed to correctly align the travel indication marks on the chuck and master jaw. Check the indication marks in the clamped and unclamped states and adjust as necessary. With the draw nut set in its final position, Andrew installs the dust cover and one of the top jaws, torques the chuck screws, and installs the remaining top jaws. If you are working on a Haas toolroom lathe, the chucks on these machines need to be adjusted for runout when they are remounted, since the chuck does not locate directly on the spindle taper. Andrew attaches an indicator and sets the indicator stylus against the chuck body. The chuck on this TL-1 has been serviced and reinstalled, but the mounting screws have not been tightened yet. With 3 of the 6 chuck screws loose and the other 3 just snugged, and an indicator in place. Check the radial runout of the chuck. Given Andrew's indicator position, it will be easiest to tap the chuck away from him. Therefore, he finds the high point of travel. Then he uses a light mallet beside the indicator to tap the chuck away from the high point. Tap until the chuck has moved to the midpoint of the total runout. Repeat this sequence of finding the high spot and adjusting out half of the error until the runout is reduced to less than 5/10,000ths. Carefully seat the screws in a star pattern and torque them to the recommended value. Finally, recheck runout one more time to verify the chuck did not shift during tightening. Unfortunately, there are times when chucks aren't properly maintained. Let's look at the results you should expect when chuck maintenance is neglected. If you find that the draw nut area is covered with accumulated dirt and debris, you should first clean the area to evaluate the extent of the problem. You may find, as Andrew has here, that there is significant corrosion where the draw tube and draw nut fasten together. Once suitably clean, attempt to remove the draw nut. If the corrosion damage prevents the nut from unscrewing easily, resist the temptation to use cheater bars or hammer blows to increase the amount of force delivered to the draw nut. This will only damage the nut and the tool, making it impossible to rotate. Penetrating oil can sometimes be effective in loosening rusted draw nut threads. Spray the oil liberally in between the threads and allow it to sit overnight. If the penetrating oil doesn't do the trick, contact your local HFO for information on more involved disassembly methods. And remember that all this headache can be avoided if the chuck isn't neglected, but instead is maintained at regular intervals. Thank you for watching this lathe chuck remove and replace video.